6.7, areas of quadrilaterals. By the end of this lesson, students should be able to calculate the area of quadrilaterals. So we already know some of the formulas for the area of quadrilaterals. Some like, let's say rectangle, which is area is equal to the base times the height of the rectangle. You have the area of a square. An area of a square is just side times side, so it's side squared. And that's really all that we knew before. But some of these are very similar. So for example, the area of a parallelogram is also base times height. Now the way that you have to calculate the height of the parallelogram is going to be the distance between the bases. So you would just make sure that you have one of the sides and then the distance in between that and its parallel side, and that would be the height of the parallelogram. Area of a kite is going to be 1/2 diagonal 1 times diagonal 2. So what you would need to find first is you'd have to know the measures for those two diagonals, and the length of one of these would be considered your diagonal 1, and then the length of the other one is going to be your diagonal 2. And once you multiply those together, you just divide by 2. Now we also have our rhombus, which is also the same formula, 1/2 diagonal 1 times diagonal 2. And then last but not least, we have our trapezoid. And the trapezoid is base 1 plus base 2 times your height, and then multiply that by 1/2 or divide by 2. And just like we had with the parallelogram, your height is going to be the distance between these two bases. And you're going to know that because it's going to be the line segment that's perpendicular to both of the bases. These are all the formulas. I recommend that at this point you go ahead and add them to our tree of quadrilaterals, and we're going to do a couple practice problems. So this next practice problem is asking us just to calculate the area of each quadrilateral, and we know that the area of a trapezoid is going to be 1/2 base 1 plus base 2 times height. And so you want to make sure that you get your key pieces of information. So I like to sometimes write this down off to the side so it's easy enough to substitute in and solve for. So I know one of my bases is 14, another one of my bases is 6, and then last but not least, my height is going to be 7. So when I go ahead and substitute these values in, we will have 14 plus 6, and then our height is 7. And we can just begin to simplify. So I have 1/2, 14 plus 6 is 20, and then times 7. And I'm going to go ahead and continue to simplify, or you can just simply use your calculator. So I'm going to use 1/2. 20 times 7 is going to give me 140. And then half of 140 I know is equal to 70. Now since we're dealing with area, this is going to be measured in units squared. And you can just write that just like I did just there. So the area of our trapezoid there was going to be 70 units squared. Next up we have what is a rhombus, and we know it's a rhombus because all of its sides are congruent. And we can see that the diagonals, both of these are 8, so they're bisected, but they're not the same, so we know it's not a square. So the way that we're going to solve for this is using the formula for the area of rhombuses, which is 1/2 diagonal 1 times diagonal 2. Now remember that our diagonals are talking about this entire distance all the way across. So one of my diagonals is going to be 22 units long, and then my other diagonal I can say is going to be 16 units long. So when I substitute those values in, we have 1/2 22 times 16. Alright, so if we start to simplify, we can say 22 times 16 is going to end up being 352. And then we just need to take half of that. So we're going to end up with 176. And remember, we're calculating area, so this is going to end up being 176 units squared. So the area of our quadrilateral here, which is around this, is going to be 176 units squared. That's pretty much it. But what we can start to do is put this all together and work backwards. So here we have a parallelogram, and we can see that because we have both pairs of opposite sides that are parallel, and we're given that the area is 60 units squared, and we need to solve for the height. Well, my area of a parallelogram is just base times height, so I'm going to start off with that. And I know that my base is 6, my height is what I'm trying to solve for, but I know that my area is 60 units squared. So we can just substitute those values in to our equation. So area is 60, my base is 6, and my height is what I'm trying to solve for. So I'm going to leave that as a variable. And then if we solve for h, we can divide both sides by 6, and we end up finding out that 10 is equal to h. So this means our height is going to be 10. Now since it's just a segment and not an area, we're going to say our height is going to be 10 units. It's not going to be units squared, but just plain old units. One last thing we can do is, let's say, a challenge, but we can figure this out. Let's say I want to build a patio, but I need to determine how much area the design will take up in my backyard. And we need to figure out this formula, or at least to figure out the area of the figure. Now there is no formula for weird L-shaped patios, so what we need to do is start to break it down the best that we can. And I can separate this into two different parts, one rectangle here and one rectangle here. And I know that if this is 3 meters long here, it's going to have to be 3 meters long on the other side. And if this whole entire side is 10, the remainder that I have here is 7. So I'm going to call this part A and part B. Now if I figure out the area of A and I figure out the area of B, I can add them together to come up with the entire area of this patio. Since both of them are going to be rectangles, I can just say that this is base times height, and the formula for area here is base times height. And then we can just go ahead and solve. I'm going to change this to red so we know that we're working with two different ones. So the base of my part A is 4, and my height of part A is 7. So when I'm calculating the area of A, when I simplify, I find out that this is 28 meters squared. And then switching back over to blue while we work with the area B, my base here is 12, and my height is 3. So when we finish simplifying, we're going to find out that our area of B is going to be 36 meters squared. And to find out the area of the total, then we'll just go ahead and take area A plus the area of B, which is going to be 28 plus 36, and we find out that our total area will end up being 64 units, 64 meters, because we know our units squared. And that's pretty much it. So we'll practice some more tomorrow, but now it's time for our joke. And our joke for today is, what do you get if you cross a Frosty the Snowman with a polar bear? And this is hypothetical, of course. Well, what kind of food do you get? You get a burger.